Hello everyone, we're standing here today at the Hydrogen Technology Expo, organized by Trans Global Events. My name is Johann Wiebe from Hydrogen Standard. We're standing here today at the booth of Sumitomo SHI-FW. With me here today is Frank and Mohamed, and Frank, Mohamed, great to be here.
Thank you, great to be here, Johan.
Thank you.
Fantastic. We'll have a couple of points for both of you guys. We'll start off with you first, Frank, and then we'll move over to you, Mohamed. The subject of the conversation is going to be gasification and sort of carbon capture, utilization storage, or CCUS. Focusing on the gasification side of things, maybe in a moment. But before we do so, maybe you can give a little bit of an introduction first about the business and your role in it.
Yeah, thanks, Johan. Happy to do that. So first of all, we are part of the Sumitomo Heavy Industries Group, and we have about 1,800 great professionals working in 14 countries to serve our customers. So we provide technologies and solutions that help our customers to decarbonize their businesses with a focus on energy and hard-to-abate industries like waste to energy and cement. So to do that, we have a very diverse portfolio, including post-combustion carbon capture to take CO2 out of flue gases, for permanent storage or utilization like synthetic fuels. We also offer gasification technology to turn biomass and waste into sustainable fuels. We have our traditional solutions like biomass to energy, waste to energy for low carbon dispatchable energy, heat and power generation. And then we have long duration energy storage to help stabilize the grid when the penetration of renewable energy sources increases. So all that is supported by a wide range of services, lifecycle services to support our customers. And in short, we are here to drive decarbonization in energy and industry.
Okay, Frank, what about the demand side of the equation in the sustainable fuels industry? How is that evolving?
Yeah, great question. So, like I said, I mean, there's going to be also demand for liquid fuels in aviation and shipping going forward. It is estimated that to reach net zero by 2050, aviation needs 350 million tons of sustainable aviation fuels, and shipping about 400 million tons of green methanol. And we still need biogenic sources to generate all that fuels. And we have developed our gasification technology now for about 40 years, so it's really optimized, it's well proven, and it lets our customers turn these biomass and waste streams that they have into versatile gases that can be refined into sustainable fuels, and allows them to replace fossil fuels and move forward to a decarbonized future in transportation.
Great, excellent. Gives us a good opportunity to move to the next point, so the decarbonization and the carbon capture, utilization and storage, or CCUS. Mohamed, maybe you can give a bit of an introduction and also on the subject and what you guys are doing in that space.
All right, thank you. I mean, first of all, we're very happy and excited to be part of the event here and the growth of the event and the market for CCUS. Maybe just a bit of a background on us. We're a technology supplier and solution integrator. So we provide an end-to-end solution for capturing CO2, conditioning it for the purpose of transport, storage, utilization. So with that background, we provide 3 different solutions within that portfolio. They bring different added value for projects. So our starting point is, of course, looking at the case study with our partners, understanding the drivers for the project and identifying which technology fits best for the feasibility of the project. The first one we have is called Oxy Fuel. So it's kind of a pre-combustion process where basically instead of combusting fuels to produce CO2 that's very diluted with nitrogen, we combust it with oxygen. So you produce the CO2 directly during the energy generation process, which significantly reduces the cost of carbon capture. Traditionally, these oxygen combustion plants were connected with, let's say, air separation units to produce the oxygen. We see now with the growth of green hydrogen, a lot of oxygen is available as part of a sector integration opportunity, where that oxygen can be used for the purpose of carbon capture, reducing the cost even more.
So, sorry to delve into that. Tell us a little bit, if maybe for someone that doesn't completely understand the process, including myself, what sort of benefits the oxygen that, particularly from electrolysis, now is readily available if we're going to produce hydrogen that way. how that's going to be used in your combustion process, and what sort of benefits it gives, and how it's sort of reducing the carbon dioxide actually in that process too. Please.
Thank you. That's a really good question. I think that's really the key point, underlying point of the technology added value. So we call it SFW Oxy Plus because it brings beyond just capturing CO2, the sector integration opportunity. But the idea is instead of combusting fuels with air, you combust it with only oxygen. So oxygen and fuel gives you CO2 and water vapor.
So the nitrogen is left out of it.
Taken out of the equation. And typically, when you have energy consumed for the purpose of carbon capture, is to take the CO2 separated from the nitrogen. So we already do that in the initial step. Like I said, significantly reducing the cost of carbon capture for the project.
So, continue, maybe you want to add on to that, I'm sure of it, but cost is super important. Maybe sort of I can delve into a question that supports that aspect. How do you see then the general industry of CCUS evolving? What sort of role do you guys play in that? Also reducing the cost of sort of like utilizing that technology.
Yeah, like I said, we're a technology supplier and end-to-end solution integrator. So we are very conscious of making sure that the solution is catered for the purpose of the project, specifically addressing how to reduce costs associated with carbon capture. Because at the end of the day, this is an additionality to existing industrial plants. And we want to reduce the technical risk of that additionality, but also the feasibility, financial feasibility risks of that. So we develop it from a technology perspective, but also looking at this, like I said earlier, the sector integration opportunities that we have.
Great, Mohamed. So we discussed oxygen combustion, but you also address post-combustion carbon capture technologies. Can you talk a little bit about that, please?
Definitely, thank you for the question, because obviously we look at implementation on Oxy Fuel, but some industrial assets, they use different combustion systems that we cannot apply Oxy Fuel. And obviously there we look at the post-combustion capture route, and there we have actually two different solutions. First is called HPC Plus, which is short for hot potassium carbonate, which is a liquid solvent solution. And the other is called Cal Plus, which is calcium looping, which is based on a solid sorbent. If I start with the first one, HPC Plus, it's an inorganic solvent that we use to capture CO2 efficiently while driving the carbon capture plant using electricity, which is a way to decouple your carbon capture plant from your existing industrial plant. Another key advantage of it, besides running it on electricity, that the energy that you put in the carbon capture, you can actually recover in the form of district heating. So going back to the additionality, so beyond just capturing CO2, we electrify your carbon capture plant and you produce a side product, which is district heating.
Plus the efficiency goes up of the plant?
Of course, yeah, to a certain extent, of course. That's connected to the capture rate, so industry standard, up to 90% that can be achieved with the capture system.
Second solution you mentioned?
The second solution is called calcium looping, so it's a natural sorbent based on calcium, and that's typically a good fit in our view for heavy industries. Why is that the case? Because in heavy industries, they have a challenge to decarbonize Scope 1 emissions, which is the CO2 coming from the process, but even Scope 2 emissions, which is the energy-related emissions. In calcium looping, we call it an integrated carbon capture and energy generation, where we capture the CO2, we produce energy that covers the demands of the existing plant, and then we produce calcium oxide as a byproduct, which is a feedstock for steel, cement. So really, again, a lot of added value that comes with the carbon capture project to our partners.
Taking it away, fantastic, very thorough explanation from both Mohamed and Frank. Thank you very much, and enjoy the rest of the show.
Thank you.
And thank you, appreciate it.